In this video lecture, I will design a one-way slab. So this problem I take it from your book for 4-26. So here there is a slab. This side is 16 feet. This side we do not know, maybe many. So it is a one-way slab because this side is huge, long. Live load given is 100 psf, 100 psf pound per square feet. Rho given is 0.18 FMC over Fy. Now, most of the cases rho is not known. Rho is not known. We need to assume or we need to select. Material properties. Materials to be used is 4 KSI concrete, 60 KSI steel. So now we will start designing this slab. Now, how to design? So we assume a 1 feet strip. We assume a 1 feet strip. Say this portion is 12 inch. So we assume a beam. So this is 16 feet. And if I draw the cross section, cross section, this is 12 inch. This portion we do not know. We will design this. Also we will design the reinforcement. Okay, so step number 1, we should check with the minimum thickness. So step 1, A is mean. What is the equation? L over 20. Where I got it? Table 4-1 in your book. Or for a simply supported solid beam, the A mean should be L over 20. Again, this ACE mean is not a structural criteria. It is just a aesthetic vibration. Yeah? If you do not follow this, no problem. In fact, if it is huge, I will not follow it. But I am checking, okay, how much? 16 feet times 12 inch divided by 12. 16, 12 divided by 20, I got 9.6 inch. Yeah, this is huge. For a slab, only 100 psf load. 100 psf means in 1 square feet, 100 pound. That means only one person or something like this. Yes, only one person will start. It is not a huge load. So this is huge. I can continue with using this, but to me it is way high. But I will use, let us discard A's mean criteria because it is huge to me. I will assume A is how much? 5 inch. 5 inch. So that my D is 4 inch. Something like that. I will assume that. Let us check whether it works or no. But again, you can continue using this, no problem. Or at the same time, or okay, I think you will not like me to do this. Maybe you will like to do this. Do this, okay? So I will assume ACE is 9.6. So I will assume ACE is 10 inch. And what is my D? D will be, if I put reinforcement here, deducting 1, maybe 9 inch. 9 inch. Okay, continue using this. There is no unique solution. Somebody may think, oh no, I will not use this. It's huge. I'll use less because for my structure, vibration is not a problem. For that case, you can decrease it. Okay, so step number 1 is done. Step number 2. Step number 2, we should deal with self weight. Self weight or the dead load. Here there is no other dead load. How to find the dead load? This slab, we know that side, and that side is, this side is 12. This side is 12 and this side is 10. Height 10 with 12. So self weight will be 12 divided by 12, 10 divided by 12, it is feet times 150 pound per cubic feet. Where I got it? The unit weight of reinforced concrete is typically 150 pound per cubic feet. So if I divide 10 divided by 12, 150, I got 125 pound per feet. This symbol we use it for pound. What is my load? 100 psi. Okay, I will erase some space here. This is done. What is my, then step number 3, load. What is my live load? 100 psi pound times 1 feet. Why 1 feet? This is 1 feet that way. So this way I will get 100 pound per feet. Dead load I got 125 pound per feet. What is my uniformly distributed factor load? 1.2D plus 1.6L. So 1.2D is 125, 1.6L. L means live load. Again, before I forget, in your book, if you read your book, they told that solve this problem neglecting the ACE mean criterion. But again, you can do that. But here, what I am going here, I am not neglecting that ACE mean criterion. You can neglect, no problem. That is up to you. If you neglect, there will be vibration. But I am doing this way. Procedure same is just that like your assumption or your consideration. I'm just showing the procedure. There is no unique solution of designing. Okay, so I'll go 1.2 times 125, if I am not wrong, right, plus 1.6 times 100. I got 310. I'm doing good very quickly. Okay, so step number 3 is done. Okay, I do not need it. I need some space. So step number 4, moment. Moment is WL square over 8. L is 310 pound per feet. L is 16 feet square over 8. How much it is? I got 9920 pound feet. It was pound, it was in feet. If you multiply by 12, 040 pound inch. If you multiply by 12. So we got our moment. Next step number 5. We know that after finding moment, you saw in the beam design, we go to that size matter, like BD, like that way. Okay, so step number 5, we will do rho, because to find our size, we need our rho. But rho is already given. 0.18 F prime C Fy. 0.184 by 60. I know it will be 0.012. Let us check. 4 over 60 times 0.18, yes, 0.012. So we got our rho. Okay, I will erase here. So we got our rho. The next step is step 6. We will use table A13 to find the value of PBD square for rho 0.012, because you saw it here. If I know my rho, I can find this portion. From that portion, I can find my D required. if I do not know my row, I can, but I know my D. So both way, yes, I can go both way. Okay, let us go. So both way you can deal with this, yes, both way. Let us see in this first, what is our D required? Okay, what is this value? Appendix A13. 643.5. So from this table we got this value is 463.5 for this row. Now let us calculate what is our D required. So moment I got, okay, so if I do D square is mu, then P, then B here 643.5 here. Okay, what is my mu? 11904. Then P is 12 inch, P is 0.9, 643.5. How much it is? 119,404 times 12 divided by 9 divided by 4. Something wrong, let me check the calculation. So D square will go, this will go, oh, B will go down, sorry, B will go down. That means not here, B will go down, 12 here. B will go down. So 119,040 divided by 0.9 divided by 12 divided by 643.5. I got D is 4.13 inch and this value 17.12 something 128. Yes, so you can see that I need actually D only 4.13 inch. That means A should be plus 1 inch, 5 inch something. So that is only needed, but my D is huge. Yes, I deleted. My D cannot remember. My D is 9 inch. My ACE is 10 inch because I tried to satisfy ACE mean criteria. So this is the required. Yes, this is the required. This is the required. But to satisfy the ACE mean criteria, I have to provide 9 inch. So here we just checked. Yes, so our D 9 inch provided. Okay, yes. So we need 4.13 inch, we provided 9 inch. So good. Okay, so I do not need to go back and check my self weight because my actual required is less. I provided more, so I am in safe side. Okay, step number 6. Now I'll go to step number 7. Step number 7. Okay. So we will continue using this our bigger D. Now reinforcement. What is my reinforcement? Rho BT. What is rho? 1.12 B12 D9 inch. So 0.012 B12 D9 inch. It is 1.296 inch square. So we need this amount of reinforcement in the slab, in the 1 feet strip. Now you should select the bar. How to select the bar? Table A6, I think. Table A6 in your appendix. Yes, table A6. What is A6? If you can see here, areas of bars in slab inch square per feet. Per feet means if my width is 1 feet. My width is 1 feet because I assumed 1 feet strip, so I can use table A6. and this way bar number, this way bar spacing. I need 1.129, oh sorry, 1.296, 1.296, that means 1.296. You can see here 1.31, number 7, 5.5. If I provide 7 at the rate of 5.5 inch center to center. If I provide this, I am providing 1.31 inch square per feet. Hopefully you understood. Yes, if you go to table A6, this way bar number, this way spacing. So and this table will give you the amount of reinforcement you are providing. So if I use bar number 7, 5.5 inch center to center, it is 1.31, 1.31, 1.29, very close. So design is perfect. Okay, so main reinforcement is done. So if I draw the slab again, the slab was like this. So this way my reinforcement will be number 7 at the rate of 5 is center to center. Yeah, sometimes we represent like this, 7/8 P at the rate of 5.5 inch, I think 5.5. Sometimes we write this way, 7/8. This is called dia. This is the informal language. 7/8 is dia bar at 5.5 inch on center. That is also okay. So we got our reinforcement this way. Done. What about this way? We need to provide temperature and flexural reinforcement. Say step number 8. Temperature and shrinkage. What is the rho? It is in your book also. For 60 grade steel, rho is 0.0018. So 0.0018. Okay, find the reinforcement is rho B is. Something to note. I wrote here rho BD. I wrote here rho B is. So what is the difference between this? This is my flexural reinforcement. Flexural reinforcement, D is my governing dimension. Rho B is, my whole slab will contract, expand. So for this case, I have to use the gross area. So B is. Okay. So if I use it, I can do it here. Okay, right here, 0.0018. B is 12 inch, Ace is 10 inch. So rho is 0.0018. B is 12 inch, Ace is 10 inch. That time T was 9, not 10. So 0.0018 times 12 times 10. I got 0.216 inch square reinforcement. Very small reinforcement per feet. 0.216. Okay, so if I go to that table again, 0.21. 0.21. I got 0.20, 0.24. So 0.24. If I use number 4 bar at 10 inch on center, it is okay. But I am finding a better option. I will show you how it is better. 216, right? 216. That is a better. There is no other. 0.24. I think that is the best option. Number 4 bar at the rate of 10 inch on center. That is a better option. Okay, so we are done. So design is almost done. Now I need to do some detailing. So last step, detailing. So draw the slab. This is 16 inch. Uh, oh, so now I have reinforcement this way and that way. Which layer to put in the bottom? One reinforcement is here, other is that way. Should I provide that way, down or up? That is something to think. It must be up. Now why up? Because temperature and shrinkage reinforcement ideally should be at the middle of the section. But it looks very odd. One layer here, other layer here. So we try to put it on top of this bar and then tie using this GI cable. Okay, so what is this? This one is this. This is this reinforcement, and that reinforcement, this. So this reinforcement is that. As I know my dimension 16 feet, I exactly know how many bar do I need. So 16 feet times 12. Total here is 192 inch. Every 10 inch I am providing 1. So divided by 10. So 19. So so I need 19 bar. 19 bar. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 bar. You can write here 19 number 4 bar at the rate of 10 inch. And for 2 inch, actually 20 bar is good enough. 20 bar is better because it is 192 inch. Every 10 inch I am giving 1. So 19.2 bar. I cannot provide less. I can provide more. Okay, provide one more. 20 bar. 20 bar number 4 at the rate of 10 center to center. So now finish it. This is 10 inch. And what else? This is 16 inch. And then I think right here 0.75 inch cover. Yes, cover. Yeah, so hopefully the design is done. Now something else, at the very beginning you may not use the ACE-min criteria. In that case you will proceed with, you will assume some value and then continue. If the required is less than that, good. Otherwise go back and check. And you saw that designing is like there is no unique answer. You can go different ways and you will get different answer. But do not forget to present your answer in a very neat sketch. Very neat sketch. Who will use this? Your field labor. Your field labor will see this sketch. So make sure it is very clear, clean, and maybe you can duplicate your information. So somewhere you wrote this 10 feet. So different way you can, even this side here to here, say it is 9 inch. Here to here 1 inch. So different way present your information so that the laborers can follow. Okay, so we will continue more. Thank you.